Hello everyone and welcome again to IB Master. As you see in front of you, we have a new topic today. It's logarithm. And logarithm is very interesting topic because I call it the mirror of exponent. So if your knowledge in exponents is good, so definitely logarithm will be very easy. So let's proceed to the definition of logarithm and for us to know or to have a more understanding what is logarithm exactly. Logarithm in books, they said, is a quantity representation of the power to which a fixed number must be raised to produce a given number. So if we try to have this definition in an easy word, we could say that logarithm is a mathematical operation that determines how many times a certain number, and we call it the base, could be multiplied by itself to reach another number. So, to show it in an example, we must explain the transformation process from exponent to logarithm and also vice versa. So, as you see here, if we have a to the power of x is equal y, we could represent it as log base a of y equal x. As you see, the base of exponent is also the base of the log. And the argument in the exponent, it comes directly after the log and it's equal the power. But also we must take care that a must be bigger than 0 and a also not equal 1 and y, which is the argument, must not equal 0. So for example, as you see here, 2 to the power of 5 is equal 32. That's mean log of base 2 of 32 equal 5. And as we know that everything in mathematics has properties and rules, also logarithm has 4 rules. Rule 1 is the product rule, rule 2 is the quotient, then power rule, then change of the base. So now we will begin to go deeply for every rule in the logarithm with some example for us to have more deep understanding. So let's begin with the product rule. Product rule, it state that log of base b of a plus log of base b of c is equal log of base b of a multiplied by c. So as you see here, when we add two log with the same base, and this is the main condition, it's equal log with the same base also, and we multiply the two argument. And by the way, this rule is working two-way. What that mean? That mean if we have log base b of a multiplied by c, also we could represent it in the addition of the two log with the same base b, so it will be log base b of a plus log base b of c. So if we have an example, so we could say that log base 5 of 7 plus log base 5 of 3 is equal what? We will put the log, the same base, then 7 multiplied by 3, so it's equal log base 5 of 21. So if we have another example, this is example 1, this is example 2, log of base of x of 2 plus log base x of 9 is equal log base x of 18. Also, if we have log base 7 of 48, we could also represent it as log base 7 of 6 plus log base 7 of 8. As you see, it works both sides. So now let's go to the next rule, which is the quotient rule. Okay, so what is the quotient rule saying? Quotient rule is state that if we have log of base b of a minus, this time is minus, before in product rule is plus, log base b of c, it's equal log base b of a over c. So here turn to be in a quotient form. And also remember, first it must be the same base, and also it works in both sides. So let's take as a example, we could say that log of base 3 of 12 minus log base 3 of 4 is equal log base 3 of 12 over 4 is equal log 3 of base 3. And here I will tell you one of the properties. If we have log of base a of a, it's equal 1. So this is a base. If the base is equal the argument, so the answer is 1. So for our example, log 3 base 3 of 3 is equal 1. Why is this? Because we know that a to the power of 1 is equal a. So if we transform it, it will be log a is equal 1. And this is a very good information, and it helps much in solving the examples. So let's go jump to the next rule, which is the power rule. The power rule states that log of base a of b, and this b is raised to the power of c, is equal c log a of b. As you see here, when we have log of base a and the argument b is raised to c, so the c is come before the log and turn to be c log base a of b. So let's take an example. If we have log base 2 of 5 to the power of 3, so it's equal 3 log base 2 of 5. As you see, the c jump to be before the log. Another example, if we have log base 2 of 16, which is, we could simplify it to log base 2 of 2 to the power of 4, which is 4 will come before 4 log base 2 of 2. And as we said, the rule log base 2 of 2 is equal 1. So it's equal 4 times 1 is equal 4. So again, also don't forget, same like the product rule, the quotient rule, also this rule, it works both sides. Also, another information I want to tell you, when we write log without any base here, it's empty, that means it's log to the base of 10. So if I have log 7, that means this is log base 10 of 7. So now we will go to the last rule in this logarithm, and it's called change of base rule. And I always call it the forgotten rule because it's rarely to be used, but especially in the exam and especially in IB exam, they like to put some example to be solved. So it states that log base b of a, I could represent it to a quotient between two logs, and could choose the base by my own, and also choosing the base is depend on the example. We had to choose it based on what the example want, and to choose the base to facilitate solving this example. So I could put it here with base c of a over b. So as you all noticed here, that we could change the base of the log and use a new base in order to facilitate the exercise and try to use other rule and try to incorporate it with the example. So for example, if I have log base 5, this is an example, of 7, I could represent it in log and log, and 7 go up, 5 go down to the base of 3. So for example, if I have log base 81 of 27, so as I see here, 27 is a result of exponent of 3, 81 is the same, or for example 9. So if we said this is equal log, I put 27 and here 81, and I could put, for example, 3. And also I will think about what is 27 as an exponent for 3. I will find it 3 to the power of 3, and 81 is 3 to the power of 4. So here I could use the power rule and put all the power before the logs, so it will be equal log base 3 of 3, and 3 is here before, and here 4 log base 3 of 3, and as we know that's log 3 is 1, also here is 1, so the answer is 3 over 4. So now we come to the end of this video. After we explain what is the definition of logarithm, what is the rules, what is some base and basics we got from the logarithm rules, and I hope you already got a very deep understanding for logarithm and its rule. And as usual, we will see you in the next episode, where we will try to solve more example. But before leaving you, I want to remind you to subscribe and like and try to activate the bell to get any new video we'll put it in our channel IB Master.